In this lesson, we will determine whether a statement describes a one-dimensional, two-dimensional, or three-dimensional measure. As an introduction, a line segment can be measured by length. A line segment is one-dimensional. A rectangle can be measured by area. A rectangle is two-dimensional. And finally, a box or rectangular prism can be measured by volume. A box or rectangular prism is three-dimensional. To expand on this idea, we define a line segment as being one-dimensional. We can say that an object is one-dimensional if at each location there's only one independent direction to move within the object. For example, in a one-dimensional world, a creature could only move forward or backwards. Some examples of one-dimensional objects are line segments, the outer edge of a circle, the line segments making up a rectangle, or the edge where two walls meet. All these can be measured in length. We talked about different types of quadrilaterals in a previous unit. Quadrilaterals are examples of two-dimensional objects. We say that an object is two-dimensional if at each location in the object there are two independent directions along which to move within the object. For example, in a two-dimensional world, a creature could move forward or backwards, as well as left or right. Some examples of two-dimensional objects are a plane, not an airplane, but for example the coordinate plane, the inside of a circle, the inside of a rectangle, the surface of a wall, or the surface of the base of a box. Notice all of these two-dimensional objects can be measured by area. And finally, a cube is an example of a three-dimensional object. An object is three-dimensional if at each location there are three independent directions along which to move within the object. For example, our world is three-dimensional. We can move forward or backwards, left or right, as well as up or down. Some examples of three-dimensional objects are the earth, the inside of a box, the feathers that fill a pillow, or the contents of a soda bottle. Notice all of these objects can be measured by volume. So going back to our problem, we are asked to determine whether the following describe a one-dimensional, two-dimensional, or three-dimensional measure. For short, we can say 1D, 2D, or 3D. So first we have the distance from home to campus. We measure this as a length, and therefore this is one-dimensional or 1D. B, the height of a ketchup bottle. This would be a length measured by a ruler or a tape measure, and therefore this is one-dimensional. C, the amount of bottle covered by the bottle label. Well, the bottle label would cover a certain area of the surface of the bottle, and the area is two-dimensional, and therefore C is 2D. D, the amount of ketchup that a bottle will hold. This amount would be a volume. Volume is three-dimensional. E, the amount of tile needed for a bathroom floor. This amount would be a number of square feet or area, and therefore the amount of tile would be two-dimensional. The amount of baseboard needed for the bathroom. We order baseboard based upon linear feet, which is a length, and therefore this should be one-dimensional. Even though a baseboard is a three-dimensional object, we do measure it in linear feet, and therefore we do classify this as one-dimensional. G, the amount of paint needed for the bathroom walls. We need to be careful here because the bathroom walls would be two-dimensional, but we order paint based upon the number of gallons, which is a volume, and therefore the amount of paint is three-dimensional. The depth of a bathtub is a length or distance, and therefore this is one-dimensional. The footprint of a bathtub indicates how much space on the ground the bathtub takes, which would be measured as area, and therefore the footprint of a bathtub is two-dimensional. And then finally, the amount of water that a bathtub will hold would be a volume, and therefore the amount of water is three-dimensional. I hope you found this helpful.